this assessment, we're given a reaction that, based on our previous understanding, we think should occur. In essence, we're setting this up to think about it as a primary alkyl halide with a good nucleophile and considering the possible substitution as a product. Now, we can draw an arrow pushing mechanism to show that good nucleophile, primary alkyl halide, that those are perfect SN2 conditions. And yet the problem tells us that doesn't happen. So why not? It must be that something else happened in its place. Recall that all nucleophiles, especially strong nucleophiles, can also sometimes react as strong bases. The pKa of the conjugate acid of the acetylide ion, let me draw acetylene, the pKa of this is 25. So this is, in fact, the acetylide ion is, in fact, a strong base. Do we have an acidic proton in solution or in the reaction that could interfere? In fact, we do. This hydroxyl group has a pK of 16. And so what's happening instead of the substitution is simply the deprotonation. Anytime we have a competition between a substitution and an acid-base reaction, the acid-base reaction will usually be the faster reaction. That's the case here. It prevents this nucleophile from displacing the chloride. Instead, it acts as a base to simply deprotonate the hydroxyl group.